Alright, so today we're going over instantaneous acceleration in physics. So there are some few essential things to know here. So in order to find acceleration over an interval, you would take delta v, which is v final minus v initial, and then put it over delta t, which is the initial time versus, rather the final time versus minus initial. And then to find final velocity, you would take initial velocity and then add it to the area under the graph of the acceleration graph over the interval, which is basically the integration of the acceleration graph over the interval of a to b. And then these are just, I guess, some rule of thumbs. So if a graph is a position function, the derivative of the position function graph will be the velocity. The derivative of the velocity graph will be the acceleration. And then vice versa, antiderivative of acceleration will be velocity, and then antiderivative of velocity will be position. Alright, so let's take a look at number 31. So this figure shows the acceleration versus time graph of a particle moving along the x-axis. Its initial velocity is 8 meters per second at t equals 0. What is the particle's velocity at 4 seconds? So we're given this graph from the interval of 0 to 4, and let's use this equation right here. So let's use v final is equal to, since we're finding out v final is equal to v initial plus the integral of the acceleration graph over, in this case, a is going to be 0, b is going to be 4. So let's write out what we know. We know the initial velocity, which is going to be 8 meters per second, so it's going to be 8 plus the integral of 0 to 4, that's going to be our interval of the acceleration graph, so as dt. But we're not given an equation here, so we could actually just look at the graph here. And what we could do is just find the area under the graph. So it would just be everything under this line right here down to the x-axis. So let's calculate that. So in order to find the area, let's break it up into two shapes here. Let's break it up into a triangle and then the rectangle. So for the triangle, we're going to have a base of 4, and then we're going to have a height of 2. And then for the rectangle, we're going to have a base of 4 and then a height of 2. So we're going to get 4 times 2 divided by 2, which is 4. That's the area of the triangle. And then 2 times 4, which is going to be 8. And then 4 plus 8 is going to be the area under the graph from the interval of 0 to 4, which is 12. So our V final is going to be equal to 8 plus 12. So V final is going to be equal to 20 meters per second. And that is your answer. Alright, so let's take a look at number 33. So calc A's particle is moving along the x-axis and has a position described by the function 2t cubed plus 2t plus 1, where t is in s. At t equals 2 seconds, what are the particle's position, velocity, and acceleration? So like we talked about before, to find our position, we're going to use 2t cubed plus t2 plus 1. But to find the velocity, it's going to be the derivative of that. So we can just use the power rule. That's going to be 6t squared plus 2. And then to find the acceleration, we're going to find the second derivative of the original equation, which is derivative velocity, which is going to be 12t. And now all we need to do is just plug in t equals 2 to each of these. So if we plug in t equals 2 to a position, it's going to be 2 cubed plus 2 times 2 plus 1. And 2 cubes is 8 plus times 2 is 16. Plus 8 is going to be 24, plus 1 is 25. So our position is going to be equal to 25. And I should rather put equals p. And then to find our velocity, we're going to again plug in 2 into a velocity equation, which is going to be 2 squared plus 2. And that's going to be equal to 4 times 6, which is going to be 24, plus 2, which is 26. And we'll just make that equal to v. And then the acceleration is just going to be 12 times 2, which is equal to 24. And that's going to be equal to a, which is acceleration. So those are the particle's acceleration, position and velocity at t equals 2. Alright, so let's move on to number 32. So this figure shows an acceleration graph for the particle that starts at rest at t equals 0. What is the particle's velocity at t equals 6? So again, we have an acceleration versus time graph here. So what we could do is find the area under this line right here, and that'll give us the final velocity. So again, we would use this equation: Vf is equal to V initial plus the integral of the acceleration versus time graph. But since it starts at rest, this particle, our V initial is going to be equal to 0. And all we need to do is just find the area under the graph from the interval of 0 to 6. So again, let's break it up into two shapes. So let's break it up into two triangles right here, one to the left and one to the right. So if you break it up into two triangles like that, we're going to have, I will put the other triangle right here, where this first triangle, the bigger one, is going to have a base of 4, and then it's going to have a height of 10. And then the other one is going to have a base of 2 and a height of also 10. And now if we find the area of both triangles, it's going to be 10 times 4 divided by 2, which is 20. And then the other triangle is going to be 2 times 10 over 2, which is going to be 10. And 20 plus 10 is going to give us our area under the graph, which is going to be 30. So this would be 0 plus 30. So V final is going to be equal to 30 meters per second. And that is going to be the particle's velocity at t equals 6 seconds. Alright, so let's move on to number 35. So calc the vertical position of a particle is given by the function t squared minus 4t plus 2, where t is in s. At what time does the particle have a turning point in its motion? And B is, what is the particle's position at the time? So these questions build off of each other. But if you remember from calculus, turning point in the position graph means that the position graph has reached a peak. It's essentially, let's say you're walking a certain direction, and then you start walking a different direction. In that little turning point that you're having, at some point the velocity is going to be 0. So the turning point is represented by when, in this case, y prime is going to be equal to 0. So what we do is find the derivative of t squared minus 4t plus 2. So it'll be d over dx, or d over dt actually in this case. And the derivative of that is going to be 2t minus 4. And now we need to set 2t minus 4 equals 0 in order to find the zeros of it. So 2t minus 4 equals 0. We add 4 on both sides. We get 2t equals 4. And then if we divide by 2, we are left with t equals 2. So we're going to have a turning point at t equals 2. So that answers our first question. T equals 2 is going to be what time the particle has a turning point. What is the position at the time of the turning point? So since we know turning point is at t equals 2, all we need to do is plug that into the position function. So we plug it into a position function, we're going to have t squared minus 4t, or 4,2, and that's plus 2. And then if we simplify that, we're going to have 4 minus 8 plus 2. It's going to be left with negative 2. So negative 2 is going to be our turning point, in which negative 2 would be a minimum in this function, although that's not really relevant here. But what is the particle's position? It would be negative 2. And that's, or if you want to write in a point form, it's going to be 2, negative 2. And that would be your final answer.